Welcome back. We're going to go over Algebra 2, Unit 6, Quiz 1 on properties of exponents today. And we're going to look at how we can express exponents as fractions in terms of rewriting a radical, which is our, a radical is things like square root or cube root or to the fourth root. So we're going to look at how to rewrite um, radicals as fractions and vice versa. And we're also going to go over the exponent rules, the power of the power rule, and the quotient rule specifically. So let's take a look at this first example here, and this has uh, this has a cube root of not a number but a letter. So uh, this is saying to find the cube root of a. So anytime that we have just a variable or a number by itself, that's just the number to the power of one or the variable to the power of one. So this would be the cube root of a to the power of one. And the rule for this is to write this as a fractional exponent. The numerator is inside of the radical for the exponent, and the denominator is on the index of the radical. We call that the index. So this is just a to the 1/3. So this one's going to be c. Sometimes when the index isn't clearly listed if it's a square root. So if we had the square root of 5, we don't usually write the 2 there, but you could write the 2 there as the index. That's fine as well. So for this would be 5 to the 1/2 for that one. But let's go look at a couple more examples so you can see some multiple choice ones here. Next one says, which radical expression is equivalent to c to the 1/2? So c to the 1/2, that's the same thing as the square root of c, because our index is 2, and we have the power of 1 there. That one wasn't too bad. That one's just a. Okay, so most of these are going to be in that format. Next, we're going to look at fractional exponents when we have a number that's not just to the power of 1, just pretty much just the same rule as before. So this wants us to rewrite this as a fractional exponent, and the numerator is on the inside, the denominator is the index, so this is just k to the 5/6. This one's going to just be b. Okay, we'll do one more here. And I think the multiple choice is helpful to see um, because it can highlight some common misconceptions about these problems. So when you see a fraction, your mind might jump automatically to, oh, my answer has to be in a fraction. Well, that's not necessarily true. And actually, we'll go through how to rewrite A, B, C, and D instead of just writing this. So let's go through how we would write A. So A would be x to the 1/4 over x to the 1/7. And we're not going to expand that any more than that right now because that's a bit later in our lesson right now. But that's how we could rewrite that. This next one is going to be x to the 4/7, and we can already see that our answer is going to be B here. For this next one, though, for C is going to be x to the 1 over 4/7, and that's the reciprocal, or you can think of, yeah, it's the reciprocal of that. So that's going to be x to the 7 over 4. And then this last one is saying x to the 1/4 to the 7th. So that's how we can rewrite those out. So we're going to need to use those skills a little bit later in our lesson as well. And we'll go over some details on how to solve this part here. You might already know how to solve these, and if you do, that's awesome. So this one, if we simplified that, we would use the quotient rule for this. And then for this one, we would use the power of a power rule. And we're gonna talk about that in a little more detail here in just a moment. Okay, the next part is this says rational exponents challenge. So this is going to ask us to use these different properties of exponents rules. And the properties of exponents, just make sure to look them up. You can usually find a good picture diagram of them. I think that's really helpful to see a diagram of all the properties and just have that next to you while you're working on this. So this is the power of a power rule. When we have a power, this is actually a k to the power of 1/8, and then that's raised to the power of -1. So I think of it sort of like a double power. That means we're going to multiply these out. So this is just -1 times 1/8 for the exponent part. And -1 is, so if we did 1/8 times -1, -1 is -1/1. We just multiply across on the top. We get -1/8 for our exponent. So this one says A is correct, but now we have to check B and C and see if that also equals K to the -1/8. So for B, we're going to actually multiply -1 times 1/8 again, just in the different order, but that's still going to give us -1/8. So B is correct as well. Let's take a look at C. It says choose all the answers that apply. So it could be C. So let's double check. So K, this is the 8th root of K, and K is just to the power of 1. So this is K to the 1/8 raised to the -1. That's the same thing that it says here in our original problem. And so that means it's going to be K to the -1/8 as well. So it looks like all three of these are equivalent. Okay, this next one says kind of the same thing. It says choose all the answers that apply. And this one is to the 5th root, b raised to the power of 9. Okay, so b raised to the power of 9, let's start by solving it first. So b to the 9/5 is what we're looking for. So not A, not A. I'm going to put an X next to it, not A. For B, this would be 5 times 1/9 is equal to B to the 5/9. Not B either. C is just our answer that we got 9 over B to the 9/5. So that one's going to be right. It looks like just C for this one. All right. So that's, well, we'll do one more. Let's do one more. Let's try to find us a challenge question that was a little bit different, but I think these are all kind of the same. Let's just do one more just in case. All right, so this is the 4th root of x, all raised to the power of -1. So this is going to be x to the 1/4 raised to the -1 power. We're going to just multiply those. That's x to the -1/4. Okay, so not A, that says x to the -4. B is saying x to the 1/2 power to the -4 power. And so if we multiply that, we would get x to the -4 over 2. And I know that's not correct, but let's continue to simplify this. We would get x to the -2 for our final answer. So just as kind of a side note, and we you might see questions like this on quiz 1, maybe not. But this is the same thing as 1 over x squared. So that's another way we can write negative exponents is 1 over the positive of the exponent. That's an important uh, that's important to know. I'm going to just circle that in green because that's important to know, I think. Okay, the next one is going to be, this says negative, so our overall value is going to be a negative. So we automatically know that's not going to be right. And B is also not correct. It does not equal 1 over x squared does not equal x to the negative 1/4. This one is going to be negative x to the 1/4. Now, that's not the same either. The coefficient is negative, but the exponent is positive. So C is not correct either. So this one is actually going to be none of the above. Okay. All right. Now we're going to get into the quotient rule with fractional exponents. So it wants us to write an answer with just one base and one exponent. So the quotient rule says if we have the same base, which is the y in this case, we can manipulate the exponents. We can move them either to the numerator or to the denominator. I'm going to show you two ways to solve this, and I'm also going to show you how those end up equaling the same thing when we solve them both ways. So we can move these exponents, and we do that. Sometimes we learn it as doing that with subtraction, but I found it a lot easier to think about it in terms of if we move an exponent on one side of the fraction line, we change its sign. So typically we want to have a positive exponent answer for our final answer. So usually we move the lowest exponent to the other side. That usually gives us a positive answer. Um, but we can move the highest exponent to the other side also if we want to. So I'm going to start with the lowest exponent. So if we move this up here, there's a rhyme that works really well to remember this. If you bring this fraction over the line, you change its sign, or just over the line, change the sign. That's a really easy way to remember this. So when we bring that y to the 1/4 over the line, there's now just a 1 down there. It's like we've brought all of this up here. And so technically this looks like y to the 5/4 divided by y to the 1/4. And when we divide fraction or when we divide exponents, we subtract them. If we multiply the exponents values, then we add the exponents. Because we're dividing, we're subtracting, or you can think of this is 1/4. We're bringing it over the line and we're changing its sign. So this is minus 1/4. And this equals y to the 4/4 over 1, which equals y to the 1, which equals just y. The only reason I wrote the divided by there was to show you the proof of why we do over the line change the sign. You don't have to write the divided by, that's fine. Now let's try it the other way. If we bring the 5/4 down, we should also get y for our answer. So I'm going to write this one in blue. So if we bring the 5/4 down, we're left with a 1 on the top. And you might be thinking, well, that's going to give us a fraction with a 1 over something. How could that equal y? We'll see here in just a second. So this is y to the 1/4 that's already there on the bottom. And then we're going to minus 5/4 from that. So that gives us 1 over y to the negative 4/4, which is 1 over y to the -1. And we can do sort of the same thing here. We can say, well, let's bring this up here to make it a positive exponent. And we can do over the line, change the sign again. So now this is y to the 1 over 1, which just equals y. Okay, so let's try a couple more of these. This next one's not the quotient rule. This one's just asking us to do the power of a power rule again. And this one, the power of a power, again, we multiply the exponents. Now, if we had something that was like b squared times b to the power of 3, we would add the exponents. If we have multiplication with the same base, this is equal to b to the 5th. But this is the power of the power rule, what we'd done earlier, and we just multiply those. So this is 2 times 3/7, or 2 over 1 times 3 over 7. That gives us 6 over 7. So our final answer is b to the 6/7. And when you type this in, you'll probably have to do parentheses to do the fractions properly. So b to the 6/7. Our answer there. All right, this one gets a little bit tougher. This one's the product rule. And we have the same base. This is kind of like the one we did with the b squared times b cubed is b to the 5th. We're going to add these together. Except when we add 2/5 and -3, we've got to find a common denominator. So this is 2 over 5 plus we're adding the exponents. When you first do these, it's a little bit tricky, or your brain's going to tell you multiply because you see the multiplication there. It took me a while to get used to this because when I see multiply, my mind's telling me to multiply, but we have to add the exponents when we use the product rule. So 2/5 plus -3. Now we have to find a common denominator. We're going to times by 5 over 5. So 2/5 plus -15. -3 is just -3 over 1, so we multiply by that. That gives us 5. And now this is -2 plus -15 is -13 over 5. Okay, and I believe we can leave it like that for our final answer. Let me double check just to make sure here. That's over 5. Okay, perfect. All right, we'll do just one more of these. Sometimes it'll say in the question, it'll say, make sure that you write your answer as a positive exponent. But in this case, it's saying, make sure you write your answer as an exponent that's not a fraction. So we're going to do over the line, change the sign. We can do over the line, change the sign. So now we're actually bringing all that b to the 2/7 to the top. So this is going to be b to the -2/7. And because we brought all that to the top, that's all just over 1. And that just equals b to the -2/7. So make sure that's correct there. Okay. All right. Now we're getting into some tougher ones that it says we can write this as a decimal. I would suggest not doing that. I would suggest following the exponent rules and writing everything um, as either a whole number exponent or a fractional exponent. So just like order of operations, We're going to start with the inside first and then work our way out. So let's start with the y squared over y to the 4/5. I like to usually bring everything to the top. That way we have something over 1. Um, you don't have to, though. And I also like to bring the smaller exponent to the top. So if we do that, we have the cubed root of, just leave that there, y squared minus 4/5, all over 1, because we brought this up here. We brought it over the line. We were changing the sign to -4/5 instead of positive. So now this becomes 2 minus 4/5, and we've got to do some fraction. We got to do some manipulation with the 2 to change it into a fraction with the common denominator. 2 is just 2 over 1, so now you have 10 over 5 minus 4 over 5 gives us 6 over 5. So that's our new exponent on this y term on the numerator. So this is the index is 3, the cube root of y to the 6 over 5. And that's all over 1. So really, we just needed to write it like y to the 6 over 5. A little more room there. Okay, now we've got to write it as a fraction with the cube root. So this is y to the 6 over 5 over 3. Now I think this is probably the toughest part. If you remember from middle school how to divide fractions, you can divide fractions by keeping the first number. So let's just focus on the exponent for a second. This 6 over 5 over 3 is a complex fraction, but we can write it like this: 6 over 5 divided by 3. And 3 is just 3 over 1. We can divide this with the keep, change, flip method. And I think we learned this in middle school. So 6 over 5, keeping the first term the same, changing the sign to multiply, keep, change, flip. And then we're going to flip the 3 over 1 and make it a 1 over 3. So now this becomes 6 over 15. And that's our final answer for this. That's our exponent. So now we have y equals y to the power of 6 over 15. And actually, we could reduce this. I just realized we can divide by 3 over 3. That would give us 2 over 5. So let's do that. Let's rewrite it just to be at proper notation. 6 over 15 probably would count as the right answer. But we do need to simplify this just whenever possible. Okay, so y to the 2/5. All right, that was a tough one. I think there was a lot of steps to do there. Here's another one. And instead of the quotient rule for the next one, we're going to use the product rule. All right. So again, we're gonna work on the inside first and then work our way out. This is a square root. The index is a 2. I'm just gonna write that there as a reminder for us. So x to the 3/4 times x to the -1. There's a times there. We're gonna add those exponents. So 3/4 plus -1. I'm just gonna say -1 over 1. So we've got to add those. We'll find a common denominator by multiplying by 4 over 4 for that -1 there. Now this is 3/4 plus -4 over 4, and that's going to give us -1/4. Okay, so that's our exponent for the x that's under the radical. So now this is square root of x to the -1/4. So that equals x to the negative 1/4 over 2. And I'm just writing my fractions that way to be a little more clear of how to keep those organized there. So now we're going to just focus on the fraction part again. I'll write it in blue so we don't get confused. So this is 1/4 divided by 2. We're going to write 2 over 1. Now we're going to use the keep, change, flip method. So this is negative 1 over 8. So our final answer is x to the negative 1/8. Just double check, make sure that's the right answer here. Okay. All right, so that's everything for quiz number 1, Algebra 2, Unit 6.